Sometimes for virtual function in the base class, there's no reasonable implementation. For example, in this class shape, there's no reasonable implementation of the function that computes the area of a shape because we do not know what shape it is. Furthermore, it is not reasonable to instantiate a base class object sometimes. For example, it is unreasonable to instantiate a shape object because it is an abstract concept. In such cases, we define the virtual function in the base class to be pure virtual. Therefore, this class becomes an abstract class. For abstract classes, we cannot instantiate objects. If you do, the compiler will report an error. The use of pure virtual functions is to provide a uniform interface. For example, this shape class has a pure virtual function compute area. This means that for any derived class of shape, if you want to instantiate an object for that derived class, then you must provide an implementation of this compute area function. For example, in this derived class rectangle, we have an implementation of this compute area function, which is length times width. Note that if this rectangle class does not provide an implementation of this compute area function, which means that this rectangle class inherits a pure virtual function without overriding it, then this rectangle class will also become an abstract class. So pure virtual functions are useful for making heterogeneous containers. Heterogeneous containers means the container that contains objects of different classes. For example, this is a vector of shape pointers, and in this vector we can push circle objects and also rectangle objects. And because of this pure virtual function, this interface defined for computing area, which means the circle objects we can call compute area, and for rectangle objects we can also call compute area. So we can go through this vector of shape pointers and call compute area on each of these pointer. So abstract classes means those that cannot instantiate objects. We have mentioned two ways to make a class abstract. One, define a member function to be pure virtual. Second, inherit a pure virtual function without overriding it. There's the third way of making a class abstract, which is to define the constructor to be protected. Why we cannot instantiate an object of a class if its constructor is protected? That's because to instantiate an object, we need to call the constructor first. But since it is protected, we as the client cannot call the constructor. Then the object is, of course, cannot be instantiated. In this example, in the binary expression class, we make its constructor protected, which makes its binary expression class abstract, which means that we cannot instantiate objects from this binary expression class. We make the constructor of a class protected only when we do not want to instantiate any object from this class. So virtual functions allow us to achieve polymorphism. So polymorphism means that we have the same code, but the same code exhibit different runtime behavior. So other than virtual functions, there is another type of polymorphism in C++, function overloading, which means that you can define two functions that they have the same name but different parameter types. For example, here we have two max functions but with different parameters. So we can call max on two integers and also call max on two doubles. When we call this max on two integers, then this function is called. When we call max on two doubles, then this function is called.